come on user-defined function, the user, whichever way they want, they can able to define here. What do you mean by modularizer? That is nothing but dividing the work into small units. What do you mean by this local variable declaration? Local variable declaration is nothing but the variables which will work only to this particular block only. When we come on testing, by taking sample data, we will check whether it is working as our requirement or not. That is nothing but testing. Welcome back to one and all. Myself, Vasanta, lecturer in Computer Science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysore. Today, we are going to start with first session of user-defined functions. Whereas in the annual exam, from this chapter, you will get 2 questions for 6 marks. One question in part A for 1 mark and one more question on part D for 5 marks. Totally, you will get from this chapter 6 marks in the annual exam. Whereas on today's session, you will come to know regarding the definition of what you mean by user-defined function, what are the advantages of user-defined functions, that is advantages of user-defined functions, function definition or structure of user-defined function, how to write the general structure to represent a function, especially your user-defined functions. When they come on function, here function, what do you mean by function? Under that advantages, how to declare, regarding that you will come to know on today's session. First, we will discuss about the definition of function. When they come on functions, there are 2 types of function. One is library function and one more is user-defined function. Whereas library function is nothing but here the functions which is already defined. Only we are using the functionalities of that. For example, by using the header file #include iostream.h or #include math.h or #include conio.h. Like that, we are using the functionalities of that by using some header files. It is already defined. Library function is nothing but here these functions are already defined and we are using the functionalities. But when they come on the user-defined function, there the user will define their own set of statement. They will develop their own type of program here. Whereas user-defined function is a function defined by the user to solve his or her problem. Here it is developed by user only. On whichever they want, on that way they can be able to develop here. Whereas in library function, there what happens? It is already predefined. We can be able to use the functionalities of that, but we are not able to change anything on that. But when they come on user-defined function, their user, whichever way they want, they can be able to define here. Their statement they can be able to write here. When they come on user-defined function, such a functions can be called or invoked from anywhere and any number of times in the program. Anywhere we can able to invoke. Invoke is nothing but called here. Anywhere from the program. How many times we want, that many times we can able to call that function. Consider we have one main program and we have one sub-program. This one is sub-program, for example. In the main program, how many times I want, that many times I can able to call the sub-program. Any number of times, anywhere in the main program, I can able to call, or we can say invoke the sub-program, and here the sub-program will perform the task and it will generate the result to the main program after processing. The purpose of using function is to make the program design process easy, understandable and thereby avoiding ambiguity. We can able to avoid the duplication also here. Complications can be avoided here. But when they come on user-defined function, it is developed by user only. Whichever the user want, on that way they can be able to develop this concept. And when they come on advantages of user-defined function, under that there are several advantages. How many times we want, that many times we can able to call the functions, and wherever we want, there we can able to call, and it helps to modularize the program. That means we can able to divide the large program into small unit, and then we can solve. That means modularity is one of the advantages. Simultaneously, all the modules can be work here. That's why teamwork is possible. Then, when you perform teamwork, then what happens? Obviously, clarity will be more here. When they come on here, especially user-defined functions, there the user can perform teamwork also. They can able to apply the modularity technique. Then what do you mean by modularity? Modularity is nothing but dividing the large program into small unit. And then we can able to solve here. When they come on advantages, if there is a set of statements to be repeated several times in the program, these statements can be replaced as a function and called whenever we required here. When you want to display some statement again and again, on that time we can use this. Only we will make that statement as functions, and whenever we want, how many times we want, that many times we can able to call here. If a task is needed in more than one program or to group of programmers, a function can be developed and made available to other programs or other programmers also. This can be available for the programmers. How many times they can able to call? They can call and they can able to execute here. And when they come on the advantages here, the programs can be modularized. What do you mean by modularized? That is nothing but dividing the work into small unit. For example, if I want to arrange one marriage function, then what I will do, I will divide that work into several parts. One has to take care regarding card distribution, one has to take care regarding food arrangement, and one has to take care regarding another work like card distribution, stage decoration, like that. It means that I can able to divide that program into small unit, then easily we can able to perform the task. It means that modularization is nothing but dividing the large program into small unit. If I divide that program into small unit, then we'll get several advantages. Simultaneously, all the work can be performed. Time consumption is very less and accuracy will be more, like that. That's why when they come on advantages, here the programs can be modularized into functions. That means small programs. Each functions can be developed independently, debugged and tested. What do you mean by debugging or testing? Whereas when they come on testing, by taking sample data, we will check whether it is working as our requirement or not. That is nothing but testing. Whereas debugging means whatever mistake we have done, the correction of that mistake can be called as debugging. For example, if I'm going to prepare a sambar, for that I will just take a sample data and I will check whether it's working as our requirement or not. That is nothing but testing. If there is any mistake, the mistakes can be corrected. That correction can be called as debugging. Whereas in this modularization, it helps to perform debugging, testing independently. Each program can be work here. If a problem is divided into sub-problems, a team of programmers can be formed to solve each sub-problems, rather solving by single person. If I'm not going to divide that problem into small unit, then what happens? Only one person has to take care of the entire working. Then time consumption will be more. Accuracy we are not going to get properly, is it no? If I'm going to divide that work into small unit, teamwork can be performed, time consumption will be less. Is it no? Accuracy will be more. And if functions are developed in a program, the number of lines decreases here. Especially more number of lines we can able to reduce here. Line number of statements are reduces here. Next we'll discuss about function definition, or we can say that the structure of user defined function. It is very important because in the annual exam, you may get this question, explain the general structure of user defined function. Whereas here, if you observe here, first you have to write the return type specifier. What do you mean by this return type specifier? For example, consider we have one main program and one more subprogram. There, after calculation in the subprogram, which type of value we want to generate to the main program. Consider one is main program and one more is subprogram. Whereas here, this written type specifier will tell you after calculation in the subprogram which type of value we want to return or we want to generate to the main program, whether it may be integer format or float format or character format or it may be word format, that it will going to tell you. The return type specifier means after calculation which type of value we want to return. That is what return type specifier. If I am going to write void, it means that after calculation in the subprogram, there is no values are generating to the main program. Then next we have to write the function name. While writing the function name, what will the subprogram name here you have to write? For example, I want to add two numbers. Then the return type here I am to write int is the return type. Then function name I am to give it as add. That means what is the subprogram name here you have to write. That is the function name. Then inside the bracket you have to write the argument list with a declaration. It means that which are the types of values which we are passing from the main program to subprogram. For example, I want to add two numbers, then two values I am passing from main program to subprogram A and B. And here you have to mention which type of value it is, which type of data type it is. On this case here I will write int A, comma int B. Two arguments we are passing from the main program to subprogram of type integer only. Then inside the flower bracket, you have to declare local variable declaration. What do you mean by this local variable declaration? Local variable declaration is nothing but the variables which will work only to this particular block only. Then it can be called as local variable declaration. But when we come on global variable declaration, there that variable will work anywhere in the program. Whereas local variable work only for this particular block only. We have to declare the variable, which are the variables we require this subprogram. For example, here I am taking int C. C is the local variable. Then executable statement 1, 2, 3, how many statements you want you can declare and with semicolon. All executable statements you have to write. Then afterwards, return expression. Here I will do the calculation, that is C equals A plus B. That is the calculation. Then after calculation, return. We are returning the value C here to the main program. Then we will close this function. It means that here inside the bracket, here you have to write the expression, which type of value you want to perform. If you want, you can write C equals A plus B, or here itself A plus B also you can write. That means after calculation, here return word, it means that this value will pass to the main program of type whichever return type we have mentioned. Now is it clear? This is the general structure of user-defined function. First we have return type specifier, then function name, argument list. Inside this flower bracket, compulsory you have to declare local variable declaration, all executable statement, finally return expression. After that, you have to close the bracket. But here, don't put any semicolon here. Just you have to close the bracket. This is regarding user-defined function. Here, argument represents which are the values we are passing from main program to subprogram, whereas return type specifier will tell you which type of value we are generating to the main program. Now, is it clear? Next, we'll explain one by one. Whereas the return type specifier, it is the type of data, the value returned by the function to other functions when it is called, which type of value we are generating. It can be char, int, float, or it may be void also. Data type void is used when function returns no values to calling function. When we want to transfer any values, any data type, then we'll mention which data type it is. If you don't want to transfer any values from subprogram to main program, then we are using void. It means that no values are passing here. When they come on function name is the name of the function. Whatever name the user wants for that subprogram, they can give. It is the name of the function. It is an identifier to identify the particular function in a program. Whereas Return type specifier tell you which type of value you want to generate, whereas function name is the name of that function. When they come on argument list with a declaration, it is the list of arguments or parameters or variables with their declaration. Each argument should be declared separately here. If you observe here, first I declared separately A variable, B variable. That means these are the values which we are passing from main program to subprogram. Here, when you come on this, each argument should be declared separately. Each declaration should be separated by comma operator here. The list should be enclosed within the parenthesis. Compulsory within the brackets, you have to declare all the variable. If you observe here, what we have done, inside the bracket only, we have declared all the variable. Whereas here also, int A, int B, it means that you have to write inside the brackets. The complete line is called function header. Note that there is a no semicolon at the end. After closing that function, there you are not supposed to put any semicolon. When we come on the next one, local variable declaration is the declaration of the variables that are used within the functions only. That variable work within that block only. Since these variables are local to the function, these variables are called as local variables. But when they come on global variables, that variables will work anywhere. But local variable will work only to that particular block only. Executable statements are the statements that perform necessary operations to solve the problem. If the function is returning a value, a return statement should be included. If you want to generate some values from the subprogram to main program, then compulsory return statement must and should you have to write. Otherwise, return statement is not necessary. If you want to pass some values from subprogram to main program, then return word, keyword must and should you have to write. If there is no value, sir, we are passing from subprogram to main program, then return statement is optional for you. When they come on, local declaration and executable statements are together called as body of the function. The local variable executable statement, both we used to call it as executable statement, can be called as body of the function. The body of the function should be enclosed within the curled brackets here, braces, or we can call it as brackets also. It means that if you observe in the general syntax, here we have brackets, local variable, executable statement. These two can be called as body of the function. Now is it clear? It means that here you observe that local variable and executable statement both can be called as body of the function. Now I am going to explain one example program for this one. Consider I want to find the largest of three numbers. Then as usual, first we have to declare the header file iostream.h. This is a supporting header file for scene as well as cout. Ash include conio.h. This is a supporting header file for clear screen as well as getCS function. Then as usual, we have to start with the main program, void main. Here, inside this main program, we are declaring prototype, that is function prototype. Here, the sub-function name we are given as biggest. Here, the return type we are given as integer. After calculation, we want to generate the result in integer format. Then, function name, here we are given as biggest. Here, three arguments, int. Three arguments we are taking. Then here, int ABC and then big. Clear screen. In the output screen, enter three numbers. We will input these three numbers. Then later on, we will invoke, or we can say that we will call the big function. Here, big equals biggest is a function name. That result will store on big. Biggest ABC. It means that here we are invoking the subprogram. Whereas here the biggest equals, it will display big value, getCH, close this. It means that this is a main program. But when we come on subprogram, after calculation, the result here we want to generate integer format. The function name we are given as biggest. Here three arguments, x, y, z. All the three we are declared as integer data type. Here we are taking one more variable, local variable, int big. Then here we will do the calculation. After calculation, we will return big. It means that this big will display, it will move to the main program with integer format. Now is it clear? This is regarding user-defined functions. Already I told you, when they come on function, two types. One is library function and one more is user-defined function. Whereas in user-defined function, user can develop their own program, own statement, local variables, whichever way they want, they can able to create here. In the next class, you will come to know the remaining concept of the same chapter. Thank you for all of you.